All right, so today's video is going to be on ecosystems, and it's going to be a review of the BrainPop videos that you watched earlier. A lot of those same ideas we're going to see again. So scientists have different ways of measuring ecosystems. You can look at the population size of the species, and you can look at the amount of energy in an ecosystem. And if you review back, abiotic factors from the beginning of the unit, if you could write 5 abiotic factors in, that'll be the first thing I check off on your notes for next class. And you might want to title it 5 abiotic factors and then write those five underneath. Okay, so we're looking at the population size. I'm going to look at two terms right now. The first one is carrying capacity. And what carrying capacity means, it's the largest number of species that the ecosystem can support over time. And as I talk through this, I'm going to look over at this picture here, not that, this picture here. So what happens is, starting in 1800, the population of the organisms starts to increase, and it increases really rapidly as there's an abundant amount of resources and space. And then, I want my little clicker back. There we go. And then what happens is eventually your population is going to it gets really big, and it starts to use up space and use up the resources in the area, and it hits its limit. And once we hit this spot, organisms are having a hard time finding food, or predators are finally catching up with the amount of the organism in the ecosystem, and then it's going to drop back down, and it might just waffle back and forth close to this line. But we see here this line that kind of goes through is the carrying capacity, and that's the number of individuals that this population could limiting factors, and that's anything that's going to restrict the number of individuals in the population. So here we've got this was actually from like a hunting website, but it listed some good ideas of limiting factors. So you could have not enough food, you've got starvation, you have disease and parasites, weather, hunting, predators. All those are going to be things that limit the amount of organisms you have in your ecosystem. Okay, so if we take, and if there's few limiting factors, birth rates are going to increase and death rates are going to go down, and this is going to cause your population to increase rapidly. This exponential growth curve, you could think about if this were a bacteria, so you could go from one bacteria, let's say Pete is eating pizza and watching a movie, and then all of a sudden his family decides that they're gonna his family decides that they want to go out for the weekend, and he leaves his pizza by the TV. What would happen is that the bacteria would fall on that pizza, and maybe there's one colony at first, and they're going to feed off the surface of his pizza, and then they're going to double, and then 2 goes to 4, 4 goes to 8, 8 goes to 16, and that would keep happening, doubling and doubling and doubling, and eventually you'd see a curve like this. This is an exponential growth curve, because our population size is going to keep doubling. That would keep happening until they hit limiting factors that would cause the population to level back off. Okay, so if there are many limiting factors, the birth rates will go down and death rates will go up. This will cause the population size to decrease rapidly. So if you had an influx of new predators into an ecosystem, it's going to cause the death rates to go up, and that's going to cause your population size to decrease. In an ecosystem, a given species, producer or consumer is going to increase in numbers until it hits its carrying capacity. At this point, it will level off and the numbers will be stable. So that's just revisiting that picture that we talked about earlier. That purple line here, this could be our predators in a population. So if they have an abundant amount of, let's say this is wolf species, and probably wouldn't be in the millions, but if we had wolves in an area and there was plenty of rabbits and mice and things to hunt, our wolf population would go up until they've eaten a lot of those primary consumers, those herbivores in the ecosystem. And then once they've eaten too many, they're going to have a hard time finding food and they're going to decrease. But eventually, those consumers are going to level off as well. In an ecosystem, you can think of energy moving in just one direction. So when we talked about water, and we talked about carbon and nitrogen, it's going to cycle through an ecosystem. Energy is going to move pretty much in one direction. It's going to go from the sun to the producers in the ecosystem. So that's always the first level. The total amount of initial energy in an ecosystem is what's going to be trapped in your producers. So if you think of a rainforest, rainforest has plenty of trees, a lot of different levels of producers. It's going to absorb a lot of the sun's energy. It's going to give off some as heat, but there's going to be a larger base of energy to use. If we were to go to the North Pole, then there's not a whole lot of producers there. Or you could think of grassland. If we went to the Midwest, some of that energy from the sun is getting absorbed by producers. Some's being bounced off and lost as heat. And then your energy gets passed from producers to consumers. In your consumers, this would be your primary consumers, like rabbits and things. The rabbits are going to eat the grass and the plants in the area, absorb some of the energy. They're going to leave off some as heat. Then the rabbit gets eaten by a hawk. The energy from the rabbit's going to get transferred in the hawk. And then when the hawk dies, its energy goes into the decomposers. Decomposers will lose some as heat. And then some of the nutrients will go back to the nutrient pool in the soil. And then the producers will take that up. So the producers will take in, if there's nitrogen, say from a decomposed rabbit, or carbon, the producers will take that up and use that to grow, and it'll get passed on again. But most of the energy, you could think of some of the energy being put into a mushroom or some other decomposer, and it might get eaten by something in the ecosystem. But for the most part, your energy is just going to flow in one direction, from the sun to producers to consumers to decomposers. It's never going to cycle back into the sun. So it never cycles like the water cycle, where it keeps going round and round. The energy is never going to get passed back to the sun. We can think of the energy in the ecosystem in terms of this pyramid. So it's a way of visualizing the amount of energy available to each link in the food web. You've got your producers on the base level. So the size of the base level of your pyramid is going to be the total amount of energy that's available for other levels. The grass gets eaten by a chipmunk in the ecosystem. The grass would pass on 10% of its energy, or this producer level is going to pass on 10% of its energy to the next level. Then when the chipmunk gets eaten by, let's say it gets eaten by a bear, it's going to pass on 10% of its energy to the bear, and on and on. Because of that, because only a small percentage of energy is passed on, you can't have 10 levels to an ecosystem. There's not like a 10th level predator, because only a little bit of the energy can get passed on. A lot of it's used for, a lot of it's given off for heat and used for energy in the organism. So that was, this slide here is just talking about what I just said. The pyramid ends at the top because only 10% of the energy is available, and it's passed on to the next level. Some of that energy is used for growth, respiration, digestion, and a large percentage of it is lost as heat. All right, that's the end of the slideshow, and we'll see you back in class.